Welcome to Thermodynamics lecture series. In the present video, we will discuss the GATE previous problem on work and energy transfer. Let's see the first problem. A polytropic process is carried out from an initial pressure of 110 kilopascal and volume of 5 meter cube to a final volume of 2.5 meter cube. The polytropic index is given by n equal to 1.2. The absolute value of the work done during the process is dash kilojoules. This problem is given in GATE 2022 for mechanical paper. Let's see the solution. So here the given process is the polytropic process and initial pressure is 110 kilopascal. Let's consider initial pressure is the P1. So P1 equal to 110 kilopascal and initial volume is the 5 meter cube. Let's consider initial volume is V1. Then V1 equal to the 5 meter cube. And also given the final volume, let's consider V2 is the final volume and its value is the 2.5 meter cube. And also given the polytropic index, let's consider small n is the polytropic index, then n equal to the 1.2. So then we have to find out the work done during the process. So we know that when the work done during the polytropic process, P1 V1 minus P2 divided by n minus 1. Here small n is the polytropic index. So here it is given the P1 value given, V1 value given and n value also given, V2 also given. So we have to determine the P2 value. So we will determine the P2 value by using the polytropic process equation, that is P1 V1 power n equal to the P2 V2 power n. So have to substitute P1 equal to the 110 and V1 equal to the 5 and V2 equal to the 2.5. Then polytropic process equation will become the 110 5 to the power 1.2 equal to P2 into 2.5 to the power 1.2. So then here P2 value will become the 252.713 kilopascal. Then substitute this P1, V1, P2, V2 and n values in the work done equation. Then work done during the polytropic process equal to the 110 into 5 minus 252.713 into 2.5 divided by 1.2 minus 1. And this will become the, so 110 into 5, this is the 550 minus 252.713 into 2.5 is equal to the 631.7825 divided by 1.2 minus 1 become the 0.2. And here, so Pascal is equal to the Newton per meter square. So kilonewton per meter square into the meter cube. So meter square and the meter cube, it is the meter. Then this value equal to the Newton meter equal to the joule. Then this value is the kilojoule. So then this value equal to the work done during the process 1 to 2 polytropic process equal to the minus 408.92 kilojoules. Let's see the next problem. A mass m of a perfect gas at pressure P1 and volume V1 undergoes an isothermal process. The final pressure is P2 and volume is V2. The work done on the system is considered positive if capital R is the gas constant and capital T is the temperature. Then the work done in the process is option 1 P1 V1 ln V2 by V1, option 2 minus P1 V1 ln P1 by P2, option 3 RT ln V2 by V1, option 4 minus MRT ln P1 by P2. So this problem is given in the GATE 2017 for the mechanical paper. Let's see the solution. Given process is the isothermal process. We know that when in isothermal process temperature is the constant and PV relation is the PV equal to MRT. So here MRT is the constant, then PV equal to the constant, that is the capital C. Then P equal to C by V. And we know that when the work done, so in the isothermal process, W122 equal to integration of V1 to V2 PdV. But here work done on the system is considered the positive. So work done during the isothermal process by the system is W122 equal to minus integration of V1 to V2 PdV. So then this equation will become the W122 equal to minus integration of V1 to V2. P can be written as C by V. So C by V dV. And this equation will become the W122 equal to, so C is the constant. So then bring the outside from the integration. Then minus C into integration of V1 to V2 1 by V dV. And this equation we can be written as W122 minus C into integration of 1 by V dV is the Ln. Then equation will become the W122 equal to minus C into Ln V2 minus Ln V1. And equation will become the W122 equal to minus C into Ln V2 by V1. And we know C is the constant, which is the relation is PV equal to C, and this we can be written as P1 V1 equal to P2 V2 equal to the constant. So here we have to replace the C with the P1 V1, and work done will become the W122 equal to minus P1 V1 Ln V2 by V1. So this equation we can be written as work done 1 to 2 equal to minus P1 V1 Ln P1 by P2. So here observe the option 2 is the minus P1 V1 Ln P1 by P2. So option 2 is the correct answer. So let's see the next question. Which of the following statements are true with respect to heat and work? So first statement is they are boundary phenomena. So second one is they are exact differentials. So third one is they are path functions. So and options are given. Option A, both 1 and 2. Option B, both 1 and 3. Option C, both 2 and 3. Option D, only 3. So this question is given in the GATE 2016 for the mechanical paper. And we know that when both of the heat and work are the boundary phenomena, and work and heat are the inexact differential equations. So these are the not exact differentials, and both heat and work are the path functions. And observe the options here. Among these three statements, first and third statements are the true. So for the options 1 and 3 are the correct statements. So option B is the correct. So answer is the option B. Let's see the another problem. A cylinder contains 5 meter cubed of an ideal gas at a pressure of 1 bar. This gas is compressed in a reversible isothermal process till its pressure increases to 5 bar. The work in kilojoules required for this process is, and this problem is given in the GATE 2013 paper for the mechanical. Let's see the solution. So given process is the isothermal process, and also given the initial volume is 5 meter cube. Let's consider V1 equal to the 5 meter cube. and initial pressure of 1 bar. Let's consider initial pressure P1 equal to the 1 bar, and the pressure increases up to the 5 bar. So final pressure is, let's consider P2 equal to the 5 bar. So then we have to determine the work done during the isothermal process, and we know the equation for the work done in the isothermal process, that is the P1 V1 into ln V2 by V1 equal to the P1 V1 ln P1 by P2. So among these two equations we will be use the W122 equal to P1 V1 ln P1 by P2, because in the data it is given the P1 V1 and the P2. So substitute all the values in this work done equation. Then W122 will become the P1 is the 1 bar and V1 is the 5 meter cube, and P1 is the 1, P2 is the 5. So W122 equal to the 1 into, so 5 meter cube into ln 1 by 5. So and this equation will become the, we know that one, the 1 bar equal to, so 10 to the power 5 Newton per meter square. Then substitute this one, W122 equal to 1 into 10 to the power 5 Newton per meter square into 5 meter cube into ln 1 by 5. So here meter square and the among the meter cube is, it will be cancelled here. Then this is the, so 5 into 10 to the power 5 into, so Newton meter, which is equal to the joule ln 1 by 5. So here this will be written as 5 into 10 to the power 5, which is equal to the 500 into, so 10 cube, so Newton meter ln 1 by 5. So the, which will equal to the, so 500 into 10 cube Newton meter, so ln 1 by 5 equal to the minus 1.60943, and this value will become the W122 equal to minus 804.7189 into 10 cube Newton meter, and this is will become the minus 804.7189 into kilojoules. 10 cube is the kilos and Newton meter is the joule. So here minus shows the work is done on the system. So next problem is heat and work are option A, intensive properties option B, extensive properties option C, point functions option D, path functions. So in the previous lectures we discussed heat and work both are the path functions. So option D is the correct. So next we have to see the another problem. A pump handling a liquid raises its pressure from 1 bar to 30 bar. Take the density of the liquid as 990 kg per meter cube. The isentropic specific work done by the pump in kilojoule per kg is. So this question is asked in the GATE 2011 for the mechanical paper. So let's see the solution. We know that when in the isentropic process, so entropy changes is the 0. So ds equal to the 0. Then dh equal to the vdp. Then the work done will become the v into p2 minus p1. So in the data it is given the, so pressure is rises from the 1 bar to 30 bar. Let's consider initial pressure P1 equal to the 1 bar and the final pressure P2 equal to the 30 bar. And also given the density of the liquid is 990 kg per meter cube. So density is given. Density of the liquid equal to, let's consider rho equal to 990 kg per meter cube. So we know that one. Density rho equal to m by v. For the unit mass m equal to 1, then rho equal to 1 by v. So in the isentropic process, work done equal to W equal to V into P2 minus P1. This V can be written as 1 by rho. So then work done W equal to P2 minus P1 divided by the rho. So here it is given the P2 is the 30 and P1 is the 1, rho is the 990. Then substitute all these values in the work done equation. Then work W equal to 30 minus 1 divided by 990. So pressure is the bar and density is kg per meter cube. It will become the meter cubed per kg. Then this is the 29 by 990 and we know that the 1 bar equal to 10 to the power of 5 Newton meter square into meter cube divided by kg. So here meter square and meter cube, it is the Newton meter divided by the kg. So it is the 29 by 990 which is equal to the 0.02929 into 10 to the power of 5. So Newton meter will become the joule divided by the kg. And this can be written as W equal to 2.93 into 10 cubed joule per kg. And finally this can be written as W equal to 2.93 kilojoule per kg. We have to express this value in the kilojoule per kg. So work done by the pump W equal to 2.93 kilojoule per kg. So answer is the 2.93. So these are the previous problems. Thank you.